Hello everyone. Today we will study about flow of charge inside a wire. Free electrons move randomly from one point to another inside a conductor. Due to this random flow, net electric charge of a conductor is zero. So we have to this is the term net electric charge. We have to study this net electric charge term in the in physics. Net electric charge refers to the total charge on an object after accounting for all the individual positive and negative charges within it. Think of it like a bank account balance. You might have many deposits, protons, and many withdrawals, electrons, but the net is the final amount left over. That is net electric charge. When an external power source is attached, net flow of electrons in one direction. This movement of electrons generates a current. If there is a current of 1 ampere passing through a wire, it theoretically means that 6.25 into 10 raised to power 18 electrons are moving from one point to another in 1 second, as shown fig 1.7. Like this is fig 1.7. There is free electrons moving randomly. Net electric charge is zero. Flow of electrons in one direction. Conductors and insulators. When electrons moving among the atoms of matter, a current electricity is created. As in the case of a piece of wire, the electrons are passed from atom to atom, creating an electric current from one end to another. Conductor, the material in which the electrons are loosely held and can move easily, are called conductors. The metals like copper, aluminium, steel are good conductors of electricity. Insulators, the metal which hold their electrons tightly, do not allow the electrons to move through them. These are called insulators. Rubber, plastic, cloth, glass, dry air are good insulators and have high resistance value. Type of electricity. We have seen that electricity is a natural phenomenon as it is generated through lightning. This electricity is static in nature. Electricity that is generated in power plants is dynamic in nature. Thus, electricity can be classified as static electricity. Static electricity definition: materials are made up of atoms. Atoms are electrically neutral because they contain equal numbers of positive and negative charge. Static electricity requires a separation of positive and negative charges. When electrons do not move from one point to another, the electricity generated is called static electricity. Energy stored in electric cell or battery is an example of static electricity. Dynamic or current electricity. Current electricity flows through wires or other conductors and transmit energy to devices. Flow of electricity is positive due to the flow of charged particles like electrons. When electrons are in motion, the generated electricity is called dynamic or current electricity. Dynamic electricity cannot be stored unless it is converted to static electricity. Current flowing through electric wire and electric appliances are examples of dynamic electricity. There are some assignments. Discuss the source of electricity. Source of electricity. So there are sources. First is non-renewable energy sources like fossil fuels, coal, natural gas, oil, nuclear power. Renewable energy source, solar power, wind power, hydroelectric power, geothermal energy, biomass. Next two is this is the data sheets. टिहरी हाइड्रो इलेक्ट्रिक कॉम्प्लेक्स उत्तराखंड इंस्टॉलेशन कैपेसिटी 2400 मेगावाट. रिवर भागीरथी कोयना हाइड्रो इलेक्ट्रिक प्रोजेक्ट महाराष्ट्र इंस्टॉलेशन कैपेसिटी 1960 मेगावाट. रिवर कोयना. श्रीशैलम डैम आंध्र प्रदेश इंस्टॉलेशन कैपेसिटी 1670 मेगावाट. कृष्णा रिवर. नापथा जाखरी डैम हिमाचल प्रदेश इंस्टॉलेशन कैपेसिटी 1500 मेगावाट ऑन सतलुज रिवर. सरदार सरोवर डैम स्टेट गुजरात इंस्टॉलेशन कैपेसिटी 1450 मेगावाट. रिवर नर्मदा. टॉप 5 थर्मल पावर प्लांट्स इन इंडिया. विंध्याचल सुपर थर्मल पावर स्टेशन मध्य प्रदेश. कैपेसिटी 4760 मेगावाट. ऑपरेटर एनटीपीसी लिमिटेड. मुंद्रा थर्मल पावर स्टेशन गुजरात. मुंद्रा अल्ट्रा मेगा पावर प्लांट गुजरात. कैपेसिटी 4150 मेगावाट. ऑपरेटर टाटा. शासन अल्ट्रा मेगा पावर प्रोजेक्ट मध्य प्रदेश. कैपेसिटी 3960 मेगावाट. ऑपरेटर रिलायंस पावर. बर्रा सुपर थर्मल पावर स्टेशन बिहार. कैपेसिटी 3300 मेगावाट. ऑपरेटर एनटीपीसी लिमिटेड. Critical power hub for eastern region of India through coal. This is a collection of coal. कोल जाता है बॉयलर्स में. बॉयलर्स से बर्न होता है कोयल बॉयलर में और यहाँ पे बर्न से कोल की ऐश बचती है और यहाँ से वाटर इन पाइप्स में वाटर होता है और जिस वाटर से वाटर का स्टीम बनता है जो टरबाइन पर पड़ता है और टरबाइन को घुमाता है. जिससे टरबाइन घूमते हैं. जनरेटर से इलेक्ट्रिसिटी पैदा होती है और ट्रांसफार्मर से ट्रांसमिशन लाइंस के थ्रू रेसिडेंशियल और कमर्शियल एरिया में जाती है. फ्लाई ऐश के माध्यम से धुआं बाहर जाता है प्रिसिपिटेटर से एटमॉस्फेयर में. Electrical quantities. Current, voltage, resistance are three basic building blocks of electronic circuit. These are called electrical quantities. The energy flowing through a wire or the voltage of a battery is not visible through naked eye. An electric circuit is formed when a conductive path is created to allow free electrons to move continuously. This continuous movement of free electrons through the conductors of a circuit is called current, and it is often referred to as flow. Just like the flow of a liquid through a hollow pipe, the force motivating electrons to flow in a circuit is called voltage. Voltage is a specific measure of potential energy that is relative between 2 points. Free electrons tend to move through conductors with some degree of friction of opposition to motion. This opposition to motion is called resistance. Again, free electrons tend to move through conductors with some degree of friction or opposition to motion. This opposition is called resistance. The amount of current in a circuit depends on the amount of voltage available to motivate the electrons and also the amount of resistance in the circuit to oppose the flow of electrons. The standard units of measurement of electric current voltage and resistance are given below. Current I, unit of measurement ampere. Voltage capital V, unit of measurement V. Resistance symbol R, ohm. The symbol given for each quantity is the standard alphabetical letter used to represent the quantity in an algebraic equation. Each unit of measurement is named after a famous experimenter in electricity. The ampere after the Frenchman André M. Ampere, the volt after the Italian Alessandro Volta, and the ohm after the German George Simon Ohm. Let's find out some information about these scientists. There is no information about André M. Ampere. Next is the volt after the Italian Alessandro Volta. Now next Ohm after the German George Schumann. Now voltage is the potential difference between 2 points. Voltage is also the amount of work required to move 1 coulomb charge from one point to another. Mathematically it can be written as V is equal to W by Q, where is the voltage, W is the work in joule, and Q is the charge in coulomb. In an electric circuit, the battery is used as an electric potential. Battery is one of the source of voltage in an electric circuit. Inside a battery, chemical reaction provide the energy needed to flow electrons from negative to positive terminal. When voltage is applied in an electric circuit, negatively charged particles are pulled towards higher voltage, while positively charged particles are pulled towards lower voltage. When voltage is applied in an electric circuit, negatively charged particles are pulled towards higher voltage, while positively charged particles are pulled towards lower voltage. Therefore, the current in a wire or resistor always flow from higher to lower. A voltmeter can be used to measure the voltage or potential difference between 2 points in a system. Value of voltage is measured in volt or joules per coulomb. Symbolic representation of voltage is capital V or small v. When 1 joule of work is done to move 1 coulomb charge from one point to another, the potential difference between 2 points is said to be 1 volt. Diesel AC voltage generator, that is mechanical engine, diesel tank generator, DC voltage source interrupt. Now example, how much work is done moving a charge of 2C across 2 coulomb across the 2 points having a potential difference of 12 volt. Solution, given amount of charge Q that flows between 2 points at potential difference V is equal to 12 volt is 2 coulomb. Thus the amount of work done W in moving charge W is equal to VQ, 12 volt into 2C, 12 to the 24 joule. Assignments. More to know, when electrons move they create vacancy for other electrons. In this way the movement is repeated resulting in electric current. So there is assignment. Formula used. The relationship between work, charge and potential difference is given by W is equal to V into Q. W is the work done measured in joule. V is the potential difference measured in volts. Q is the charge measured in coulomb. Work required to move a 10 coulomb charge. Charge Q is equal to 10 coulomb. Potential difference V is equal to 20 V, 24 V. Calculation, W is equal to V into Q. W is equal to 24 volt into 10 coulomb. 24 into 10, 240. W is equal to 240 joule. Second is charge required for 12 joule of work. Work is equal to 12 joule. Potential difference V is equal to 10 volt. Calculate from the formula W is equal to V into Q. We can divide Q is equal to W upon V. Q is equal to 12 joule upon 10 V. Q is equal to 1.2 coulomb. The amount of charge required is 1.2 coulomb.